this. Okay. I started recording so I could like publish this so other people can have it too. This is the Falcon's pinion gear. We ran 10 tooth this year, right?
Yes.
That is true. I believe that is true. And they go to a much larger, everything is in configuration, 60 tooth ball shifter gear. And so if we don't worry about the shifting and we just sit in
Low.
This is low gear, right?
Yes.
Yes, that makes sense. So if we just are always in low gear, we have this like 10 to 60 reduction to this sprocket that's on the shaft. So we're just getting 60 divided by 10. So we have a 6-to-1 reduction for this sprocket. And then we reduce again going from the sprocket to the actual wheel that has a bigger sprocket on it to get to the final drive speed that we want at the wheel. But if we only want that low gear, it may not be fast enough for certain parts of the game where we want to be able to drive quickly across the entire field. Most of the time we are driving in low gear. Most of the season we were driving in low gear. How often did we shift, Jack?
I didn't shift very much.
Yeah, I was like, we did, especially in our first event, we didn't. Part of the point of having the shifter was that we can eventually get faster. So we like allow our top end speed to, as we get better, as we practice more, we can just start shaving seconds off when we need to by being able to go faster. So to be able to change gears, we have this pneumatic cylinder back here that pulls this little shifter coupler, and there's a little shaft in here that I'm going to show you in a second. And it slides back and forth, and it chooses which one of these two gears is actually engaged and connected to the shaft. The other one is just able to freely rotate at a different speed than the shaft that this sprocket is on. Okay, so let's start looking a little closer. Start hiding stuff. So this shaft right here that has this bearing on it is the actual shifter shaft. And so that's what's sliding back and forth. So as the cylinder pushes out, this whole shaft pulls with it. When it pulls in, it goes back in. If I isolate it,
The shaft is in assembly if you want to use that.
the shaft is an assembly.
With
Oh, I get what you're saying. Yeah, if I can pull out the whole shifter shaft, yeah. So this is what the little shifter shaft looks like. This raised bit is the important stuff. We'll show what that does in a second. But basically, this is how it chooses which of those two gears to actually engage and connect to the shaft so they're spinning together. So you're saying that, so this is an assembly. That would make sense. So the shifter shaft itself looks like this with the two gears on it. The shifter shaft assembly is here. So this whole piece of, this is a piece of steel. It has a little socket for a hex shaft that goes into it and it's pinned. So we can't take this little piece of hex shaft out easily at all. So it makes everything rotate together, right? And for it to be a ball shifter, this is where these little holes are, because there's actually there's 6 little ball bearings, one in each of these holes. And that's what engages or disengages the shaft. So right now we would be in, for us, what's considered high gear, so our faster speed, because where this little bump is, the ball would be sitting up higher compared to over here where the ball is basically inside this tube, and when it spins around, it doesn't have anything protruding out the top of it. I can't imagine. We didn't actually CAD the balls, right? I can't imagine we did.
no.
Yeah,
That's just pulled from Vectro.
Oh, no, they did. No, the Vectro does have the balls. Okay.
Oh.
So you can see the balls are lower, right? So as they're spinning, nothing comes in contact. They're like in the same,
Yep.
they're in the same as this circle. But over here, if I hide this gear, oh, they didn't CAD them up, but it's fine. So in reality, these would be riding higher and would basically be sticking up out of this hole so that they're touching that gear. And in a second, oh, where did the gear go? There's the gear. Okay. That's a smaller gear, but it shows the same idea. So the gears themselves have this pattern cut into them. So the balls lock into these little spots on each of the gears. And that lets it, so it forces the gear to turn at the same rate as the shaft itself. Does that make sense?
Yeah.
Where'd the other gears go? Oh, the other one was the right one. Okay, I understand what happened. Okay. So yeah, so each of these gears have that same profile. So when the pneumatic shifts in and out, one of the sets is engaged to the shifter shaft and one isn't. The back side of the gear has a bronze bushing on it, so that when it's not engaged with the shaft and the gear and the shaft are spinning at different speeds, you're not generating a bunch of friction or anything. There's a bushing in there that the gear is spinning on. So even if they're spinning at different rates, it's okay and it still works. It doesn't bind up or jam or anything else. So that's the basics of how the ball shifter works. And then you can, so basically that allows you just to select which of these two gears is spinning at the same rate as the shaft. And you can change your output speed that way if your output is going this way. You could also use it kind of backwards to be what's known as a power takeoff. If you had the motor power coming in through this shaft and spinning the shaft at some speed, you could then choose which of these two gears to like send the power to. So if you wanted to have your climber geared over here for one thing and something else geared over here for another, you could swap between those two things if you wanted to. So that's how a power takeoff works using a ball shifter. The other way to shift gears, if you don't have the Vexpro ball shifter method where you have the little ball bearings in there, you can have a dog shifter, which if I find the cat, I can pull it up. But basically there's a, instead of the little ball bearings that kind of expand into the gear, there's a gap between the two gears, and there's a dog that has like little key patterns that grabs the gear on one side or gets pulled in and grabs the gear on the other side, and it chooses which one to attach to the shaft the same way, except it just uses a little bit more width to do it. But you don't have to have nearly, you don't have to have this specialized hollow shaft or anything. It's still a slightly hollow shaft, but it's not as, I don't know, it's not as specialized as this one is. They can do it just in a hex shaft to be able to have the thing move back and forth. Our version of that, our setup for shifting this year, definitely takes a second to wrap your head around what we're doing. If I can come back to it, SolidWorks is being slow. Yeah, like as we were playing with it, and realized we wanted to do this, we definitely took a little while to figure out exactly how to do it, which gear ratios would work for what we needed to do, because we had to make this little shaft setup that Jack added that takes a separate pinion. So this is a 10-tooth sim pinion and a, what is that, 18-tooth gear. And it allows us to have this gear go from big to small, small to slightly larger, and then small to big. So we actually get, we're gearing back up. So basically we're making it so this gear is always spinning faster than this one. Almost no one would want to do that normally, right? You'd rather have, like, you'd rather use this whole second stage of gearing to get you more reduction. But because we have the extra chain reduction going to our wheels, we were okay having our low gear be our main gear ratio, and then having this one be spinning faster and give us like a, it's not really like a turbo button, but just give us a faster speed that we needed. To make this shaft, it's kind of weird. This is a sim pinion, so it's on an 8mm steel shaft with a key. So this is kind of like the same shaft that's on a sim or a mini sim. And then this gear has to be riding on a 8mm to 1/2 inch hex adapter, right, Jack?
Yes.
Yeah, so there's a hex adapter here that has the inverse of the shaft in it. Yeah, there we go. So this lets it ride on that same 8mm shaft as the pinion gear does. So the whole thing can just basically get really compact and small compared to any of the other shifting gearboxes we'd ever built. It's not that much bigger than even just a single stage gearbox. Since you're only adding a little bit of width, you're really not adding any, you're not adding a whole nother stage of gearing or anything like that like we would normally do. Okay. Questions? Did I explain that well enough?
Yeah, I think I get it now. Yeah.
But yeah, the main point of a shifting gearbox is somehow you select between two gears and choose which one of them is going to have the same is the output shaft going to actually have the same speed and torque as, and then how you actually get power to both of those depends on how you set it all up. This one is definitely a little bit more complicated than most people's, but it allows us to have smaller packaging, fewer gears, smaller gears, so it's a little bit lighter weight. Slightly smaller gears. So I guess there's smaller gears up here. They're larger on the actual shifter shaft. And then a lot of times this cylinder won't be mounted with like a plate. It'll be its own. It'll be mounted on standoffs and shifting directly in line, which is a little bit easier, but this has worked for us, so it wasn't too big of a deal. We were able to make that pretty easily. Okay, questions?